All right, we're going to try this. Hopefully this works for everybody. I'm going to use Screencastify. Uh, let's just get after it. Okay, going to start with Chapter 5. This is 5.1, Derivatives of Natural Logs. So hopefully we're good to go. All right. When you're dealing with natural logs, remember that this is your u. So the derivative is just going to be u prime over u. So for the first one, it's going to be f prime of x equals derivative of x minus 1 is just 1, so 1 over x minus 1. Call it a day. Next problem. Number 2, if you got h of x equals natural log of 2x squared plus 1, again, this is your u. So h prime of x is just going to be the derivative of u, which is 4x, using the power rule, all over your 2x squared plus 1. Don't overthink it. Can't simplify that really any other way, so just leave it. Okay. Here for number 3, we got to be able to recognize that this is going to be a product rule. All right, got to be able to recognize that that's the product rule. So when we go ahead and implement the product rule, we're looking at the derivative first times derivative of the second plus second times derivative of the first. So first times the derivative of the second plus second times the derivative of the first, which is just 2x. Okay, you can go ahead and tidy that up if you want. This is just going to be x plus 2x ln x. Bingo. All right, before I do number 4, I'm going to go ahead and rewrite this so it's a little bit easier on the eyes. We're going to get y equals, I'm going to bring the exponent out in front. Okay, you can do that using your natural log properties. When you have 1/2, you can bring it out in front. So when I look at this, that scalar is just going to stay out in front when I deal with the derivative. So this is going to end up being 1/2 times derivative of the u here, which is the u is x squared minus 4, is going to be 2x all over x squared minus 4. And if you want to tidy that up, the 2's can cancel out, so you're just left with x over x squared minus 4. Number 5, looks like we have a product rule inside the natural log. Let's see, is there any way? Well, this cubed is only going to the t squared plus 3. So when we have a product inside, we could utilize the product rule. Let me think. Separate this into y equals natural log of t plus natural log of t squared plus 3 cubed. And that cube can go down in front. So now we're going to look at taking the derivative, and so it might be a little bit easier to take the derivative here. Okay, natural log of t is just going to be 1 over t because it's u prime over u. Bring that 3 out in front. So this is going to be 3 times, well, the derivative of u here, which is t squared plus 3. So the derivative of that is 2t all over t squared plus 3. So if you want to tidy that up, it's 1 over t plus 6t all over t squared plus 3. Cool. Let's just double check, make sure we got the right answer. Let me look at my answer key here, and yeah, that's a version of it. I'm cool with it. If you want to tidy it up, you can by making it 1, but you don't have to. Okay. Here we're going to use the quotient rule with logs by separating them. So we're going to make this f of x equals natural log of 2x minus natural log of x plus 3. Really makes things easy when you go ahead and separate it like that, because now we don't have to worry about a quotient rule all over a fraction and then trying to simplify that to meet up with whatever multiple choice question we're dealing with at the end of the day. So derivative here is going to be u prime over u, so 2 over 2x, which is going to end up being just 1 over x, since that right there is a direct variation linear form. It's always going to be able to simplify when take the derivative of that to 1 over x. And then this is going to be minus 1 over x plus 3. Okay, so if you want to make it 1 over x minus 1 over x plus 3, you could even make that x plus 3 and that x, and then combine, make a common denominator. That'll be fine. Let's not, for number 7, when we look at number 7, let's not go ahead and cancel these t's. That would be way, way bad. This is just going to be a quotient rule, as simple as that. So, our derivative, as the lights go out on me. Hold on. Okay. It's just going to be low to high minus high to low, all over low squared. So low times the derivative of the high, which is just 1 over t, minus high times the derivative of the low, which is just 1, all over t squared. So then this is just going to be, well, that simplifies obviously to 1. So 1 minus natural log of t all over t squared. Okay. This right here is going to be a chain rule. So when we look at this, we're going to say derivative of the outside, leave the inside alone, times the derivative of the inside. So derivative of the outside, leave the inside alone, times the derivative of the inside. So this is going to be derivative of the outside is the natural log. So pretend like this is natural log of u. So we're looking at u prime over u, and then times u prime. Let me double check here. Yes, sir. So we're looking at the derivative of natural log of x is going to be 1 over x, and then that's your u prime, and then this is going to be your u. Okay, so when we simplify this, it really just comes down to 1 over x ln of x. And that's it. Oh, I forgot my check marks. Just to show you that we're good. Okay. I'm going to rewrite number 9. We're going to look at this as y equals 1/3 natural log of x minus 1. How about we go ahead and do another one? 1 minus 1/3 natural log of x plus 1. That'll be a little bit easier to work with. And so when we go ahead and take the derivative, it's pretty just straightforward because both of these have a derivative of 1. So it's really just going to be 1/3 times 1 over x minus 1 minus 1/3 times 1 over x plus 1. And feel free to tidy that up as much as you want, but for me, I'm okay with that. You just got to be able to make it make sense with your multiple choice answers. Okay. This one, don't get confused here. We can't really simplify this anymore. We can't pull out a 1/2. We can't make this a multiplication or anything like that using our log properties. So this is really just going to be a u prime over u situation if this whole thing is u. Okay, if you want to rewrite it to start just to show the fractional exponent, you can do that. And you might be asking, why do you always use absolute value bars? I just don't worry about the signs. So for me, I just kind of use that as a formality, but however you want to interpret it, you do you. Okay. So when we take the derivative, it's just going to be u prime over u. So derivative of x is 1. And then this is going to be a chain rule. So this is going to be pull the power down, reduce it by 1, leave the inside alone, and then multiply by the derivative of the inside. And then this will all be over the x plus square root of 4 plus x squared. So if we simplify this, that'll cancel out with that too. So in reality, I was doing all this and you guys didn't even tell me. I wasn't even looking at what was going on. Hopefully you're with me here. I was just kind of in the zone, so my bad. Again, I just rewrote that and then just did u prime over u. We don't really like negative exponents here, so that's why we try and take care of it when we can. Is it that big of a deal? Not really, but we just got to make sure that if this were a multiple choice question, we can go ahead and match up whatever we got there. So I'm going to make this 1 plus x over the square root of 4 plus x squared. And then that's all over x plus the square root of 4 plus x squared. And to be honest with you, we're not really big fans of having, fractions over fractions, but again, I'm just kind of getting through these homework assignments. So if I need to simplify that, obviously I would make this one fraction and then multiply by the reciprocal, and we'd go from there. Okay? So don't overthink it. Don't make things more complicated than they need to be. Flipping it over. This one right here, I can almost guarantee you're not going to see something like this on the AP test just because it's going to be time consuming, but we'll go ahead and take a stab at it. Just see what we got. Okay. So I got y prime equals, this really right here is just going to be a quotient rule. So this is going to be low times the derivative of the high. So this is really the same as me saying negative x squared plus 4 to the 1/2. So I'm going to make that derivative of so low to high. So low times the derivative of the high, this is going to be -1 and then x squared plus 4 to the -1/2, and then multiply by the derivative of the inside, which is just 2x. So low to high minus the high, which will turn that into a plus, times the derivative of the low, which is 4x. And then this is all going to be over the 2x squared, so that's going to be 4x to the 4th. Now this side over here, this is just going to be a u prime over u, and it's kind of a nasty one because it's going to be a quotient rule. So let's just go the long route here. So this will be -1/4, and we're going to go ahead and say, all right, this is low to high. So low times the derivative of the high. Again, this is going to be, your x squared plus 4 raised to the 1/2. So pull the power down, reduce it by 1, leave the inside alone, and then multiply by the derivative of the inside. So that's your low to high minus high times the derivative of the low, and the derivative of the low is just 1 all over low squared. Needless to say, this would be very tedious to simplify. We got a 2 here that can cancel out with one of the 2's. Same thing over here. This 2 can cancel out with this 2. But in reality, I'm not overly worried about your ability to simplify something like that. I think when I look at the answer key, there's different answers that we got here, but at the same time, I think if you kept going and really simplified, you're going to get something to the effect of the square root of x squared plus 4 all over x cubed. And that's really what we need to be focused on. Okay. Looking at the next one, okay, how good is your understanding of trig and the derivatives of trig? So this is just going to be a u prime over u scenario. So when we look at it, what's the derivative of cosecant? It's negative cosecant x cotangent x. So that's u prime all over u. So when we simplify this, we're going to end up with just negative cotangent x. Okay. This right here, we can go ahead and rewrite it to be y equals 1/2 2 plus cosine of x quantity squared. If you want to rewrite that as well, I'll raise to the, well, not raise to the 1/2 power because I already took out that 1/2. So let me get that out of there real quick. Come on, white out. There we go. Okay. And I forgot my ln there. Oops. There we go. So u prime over u. So y prime equals, remember the scalar just kind of stays put. It's glued to it. Don't really mess with it. But u prime over u. So the derivative here, well, derivative 2 is just 0. So this is going to be just the derivative of this, which is a chain rule. So 2 to the first, leave the inside alone. Derivative cosine is negative sine. And then this is all over the 2 plus cosine squared x. If you want, you can get rid of those 2's. So in reality, you're just looking at negative cosine x sine x all over 2 plus cosine squared x. Don't forget your check marks, I guess. Okay, let's double check, make sure I got the right answer on that one. And And yeah, that's what I got the first time. So we are good to go. Okay. All right. Moving along here. This is one of those problems where I'm screaming in your head that it should be the easiest problem ever, because I'm asking you to take the derivative of an integral, which is taking the derivative of an antiderivative. And so all this really is saying is, we know when we plug in 1 and then take the derivative of that, that's going to be 0, because the derivative constant is 0. So it's really just plugging in anything that has a variable component and then multiplying by the derivative of that variable component. So right here, it's going to be g prime of x equals plug in natural log of x. So that's just plugging in, and then we got to multiply by the derivative of natural log of x, which is 1 over x. Please don't overthink those, folks. Those should be candy on the AP test. All right. In this situation, we're given a function and a coordinate. And I want you to find an equation of the tangent line to the graph of f at the given point. So at the end of the day, we're going to have y minus 4 equals something right here times x minus 0. This something right here is going to be your specific derivative at 0. So what do you think we need to go find? You got to go find the derivative. So when we find the derivative here, it's going to be negative 2x, and then we're going to do u prime over u, and we're subtracting it, so it's going to be minus 1/2 all over 1/2 x plus 1. So now I want f prime of 0, so we go ahead and plug in 0. That's going to be 0, and this is going to be negative 1/2 all over 1, which is negative 1/2. So that is my slope. So that goes right there. So you're either going to see that answer, or you're going to see y equals negative 1/2 x plus 4. So either one of these represent the tangent line of the equation at the given point. Moving right along. Excuse me. Okay, page 3, used on derivatives of natural logs. We are looking at differentiating using implicit. The reason why it's implicit is because we got a bunch of y's and x's tangled together. Okay, so the first step is to identify that you are differentiating with respect to x, meaning we recognize the x terms, the x squared and the 10. These y's we have to treat like the chain rule. So this is going to be 2x, and then this right here is something that we got to be able to interpret. This is going to be negative 3, and differentiating the natural log of y with respect to x, this is going to be your u prime over u, so dy dx all over y, okay, plus 2y to the first times dy dx equals 0. So we got to find dy dx. Oh, there it is. No, we got to be able to interpret it correctly. So in this case, this is really saying the same thing as multiplying by 1 over y. So let me get rid of that divide by y. And so I'm going to get the 2x over to the other side, and I'm going to factor out what's inside here. So when it's all said and done, after I subtract the 2x, it's going to be equals negative 2x. And then we get that GCF of dy dx out, which leaves behind a 2y and a negative 3 over y. So however you want to write that. I don't usually like starting with a negative, I guess. I don't know really why. But go ahead and divide both sides by the 2y minus 3y. So we get dy dx equals negative 2x all over 2y minus 3 over y. And you can play around with that. We don't like fractions within fractions, but again, this is just algebra 2 or before, so simplifying that, okay? This says locate any relative extrema and inflection points. So that means we need to do the first derivative test and the concavity test. So let's do the first derivative test to start off. So the derivative is going to be pull the power down, reduce the power by 1. This is just going to be x minus 1 over x. That'll be a 2x over 2, subtract the 1. So we want to know, hey, where does this thing equal 0? Well, we know 0 is an issue. We know that, derivative is undefined. at x equals 0. So are there any other values that would equal 0? Well, if I solve this thing, we could go ahead and add the 1 over x over and then cross multiply. So this would be x squared equals 1. So x equals plus or minus 1. Square root both sides. Right? That makes sense. If we plug in 1, we get 1 minus 1 over 1, which is 0. So my critical values are the following three. Okay. We know that with natural log of x, we're limited on our number line. So give me 1 second here. So if you think about it, right, do we have to consider the -1? No. So let's just get rid of the -1 because we need to focus on the domain, which is just going to be 0 to infinity. Okay. So if we look at 0 and then we plug in 1, we can go ahead and say, okay, the only real possibility for an extrema is going to happen at 1. So let's look at plugging in values like a half and 10 here into our first derivative. So if we plug in a half, this is going to be 1/2 minus 2. So that's going to be a negative. Plug in 10, that's going to be a positive. So what happens right here is we're going to have a local extrema, which is going to be a local min at 1. Okay, so it occurs at 1, but it's not, the value is not 1. So we say that we have a local min of 1, and then we just plug in 1. So that's natural log of 1 is 0, so this is going to be 1 and 1/2. It occurs at 1, and the local min is 1/2. Okay, now how do we go ahead and go about our business when dealing with inflection points? We got to take the second derivative. So we go ahead and take the second derivative, and we're stemming from this. So this is going to be 1, and then this is x to the -1. So pull the power down, reduce it by 1. This will end up becoming plus 1 over x squared. There are no x values. When we look at it, there are no x values that make this 0 or make it anything that's undefined that we have to look at, because 0 is kind of like that end cap. Okay, so even if we include it, there's no values in here that we're go ahead to try and interpret. So you're really just interpreting any positive value, and that's going to get you a positive value. So it's concave up everywhere, which means there's no points of inflection. Okay, so no POIs. All right, so let's go ahead and go to our last problem, I believe. Let's double check here. Yeah, all right. Last problem here is going to be a product rule. So let's go ahead and do that for our first derivative test. So first times the derivative of the second plus second times the derivative of the first. And we want to know, where does this thing equal 0? And this is just going to be 1 equals negative natural log of x. Or we could go ahead and say, I kind of like doing it the other way. Hold on. Natural log of x equals -1. I don't know, just a kind of a formality. E both sides, and we get x equals 1 over e. So there is a critical value right here at 1 over e. Okay. Just a reminder that what's our domain? Domain is going to be 0 to infinity. Okay, same as the domain over here. It was 0 to infinity. All right, so these should be parentheses, sorry. Okay, so go ahead and interpret. Plug in 1 over e, that's kind of 1 over 2.72-ish. What are some values? Let's try like a quarter and 5. We plug in a quarter here. where do we plug the quarter into? We plug the quarter into right here, which was 1 plus natural log of x. That's what y prime is. So if we plug in a quarter, this is going to be a negative value, believe it or not, okay? Because the natural log of 1 is 0. So anything between 0 and 1 will give you a negative value. And then when we plug in 5, we get a positive value. So that right there creates that relative min that we had on the other example as well, okay? If you're kind of trying to interpret that, just plug in 1 plus natural log of a fourth. Let's see what we get. 1 plus natural log of 0.25. I got negative 0.386. So it is a small negative value, okay? So we have a relative min at 1 over e, and then we plug in 1 over e up here. And we should simplify it and get negative 1 over e when we plug it in, okay? So then let's go ahead and try and find inflection points. So finding the second derivative of this, it's actually really easy, okay? Second derivative is just going to be 1 over x, which equals 0. So we have a critical value at x equals 0, but not in domain. So there's really no place to have an inflection point because we don't have any critical values that are in our domain. So this is a no POI as well. All right, hopefully that gets you through the first worksheet of 5.1, and hopefully this works for us. It's been a pleasure doing the first video for you guys.